Today we're going to take a look at how to use Desmos when working with sample proportions. So when we're working with sample proportions, they are relatively normal as far as their distribution. And in order to use Desmos, we are going to need a mean value. We're also going to need a standard deviation. So when you're working with sample proportions, our standard deviation has to be calculated. However, our sample mean, or that x bar, is going to be exactly the same value as our population proportion, which is given to us in our word problem. In order to calculate standard deviation, you need to know your p-value. You need to know 1 minus p, or the difference, all divided by your sample size, n. And lastly, you're going to square root the entire quantity. 1,500 college freshmen were asked whether they applied for admission to any other college than the one they chose. So when I read this question, I realize that 1,500 is going to be my sample size. Assume the true nationwide proportion is 35%. So this 35% represents our population proportion. And when I'm working with sample proportions, that population proportion is exactly equivalent to my sample mean. So p-value in this case is 0.35, and the difference 1 minus 0.35. So when you put that into a calculator, you do get a standard deviation of 0.0123. You can round this to 3 decimal places or 4 decimal places. In Math 4, we typically round to 3 decimal places. So if I was to set this up for Desmos, I would have my sample mean, which is 0.35, and my standard deviation, which is 0.012. So we're going to use those values under our normal distribution for Desmos, and it is going to plot our normal distribution curve. From there, we can answer the question that's being asked here. What is the proportion that the sample will give a result within 2% of the true value? And so it fills us in. In other words, if p is equal to 0.35, so if my sample mean is equal to 0.35, find the probability that p hat is between 0.33, 0.37. So my population proportion is 0.35, and I want to know what's the probability that with this particular sample that the information that's collected amongst these college students is within 2% of what's really happening with the population, or is this a sample that represents very well what's going on within our population? So that is actually going to become our minimum and our maximum value for our function curve. So I've got Desmos here, and we are going to be using our normal distribution. So I'm going to go into functions, and I've already done that. So functions, normal distribution, and it's going to ask you for your mean and your standard deviation. So we have a mean value of 0.35 because that is my population proportion, and I have a standard deviation of 0.012. So as you can see, Desmos has drawn out your probability or your normal distribution curve. Here's where you use that 0.33 and the 0.37. You go to find cumulative probability, and your minimum value here is that 2% below the average that the question asked for, and the 2% above the average that the question also asked for. And it is asking what is the area under the curve, or the probability, or the proportion, or probability that the data will be within 2% of what's really going on. So we can say that using Desmos, we have a 0.904 0.4 as our probability, or we could rewrite that as 90.4% probability that this particular sample is within 2% of what is happening as a population.